My name is Max Bruce. I am a computer graphics supervisor at Sony Pictures ImageWorks. I have worked on about 14 or 15 different movies here for the past 10 years. Most recently, I was computer graphics supervisor on the first computer-generated animated feature from Sony Pictures Animation. And on that project, I was in charge of lighting supervision and pipeline development. I was one of the lighting supervisors on open season. As such, I represented a team of lighting and technical directors of about 20. And so every day we would meet in the morning and we'd go over the shots and I would review with the team how they were meeting the visual goals of the movie and giving suggestions. And then at some point during the day, we would meet with the actual directors of the movie and they would let us know whether we were meeting those goals or not. Lighting is where the shot comes together. The lighting technical director, as we like to say, we don't even call them technical directors here, we call them shot managers because they're the ones who make sure that the shot gets into the movie. They are the end of the pipeline, so they are usually the ones who have to figure out everything that's went wrong with the shot that happened before it. So they're usually the ones who are fixing and making the shot pretty. Aside from all that, they also have to hit the visual goals defined by the art department or the directors. There's usually a lot on their plate trying to make sure that that shot gets into the movie. The good lighter on any visual effects or animated feature generally has a very broad skill set that just comes from years of experience that allows them to fix the most minor of problems to the most major. And those most minor may be a pop in the animation or maybe an errant cloth part that interpenetrates, and those could be fixed by doing a simple rotoscoping in the comp, or they may have some significant rendering problems, a lot of chatter in the shadows and a lot of optimization problems, which means they may have to go back into the actual hardcore data, the animated data themselves, and debug why something is not rendering correctly. The production design on open season was inspired by a background artist by the name of Ivan Earl, who was a designer for Lady and the Tramp and Sleeping Beauty. And one of his hallmarks was to create a very two-dimensional, flat, graphic, stylized look. And one of our challenges was to figure out how to take this 2D look and translate it into a 3D world. When you have a very two-dimensional, iconic, stylized looking tree, it looks great and still, but what happens when you start moving the camera around it? The design falls apart. So one of our main challenges was trying to take this very 2D flat look and translate it into the 3D world. And some of the things we learned for our environmental elements, we put a lot of the elements on cards that oriented towards camera, like our trees and our bushes and our buildings. As lighting faded into shadow, we simplified our color palette so that we really limited the range of color and value in the shadowed areas. This made the hero characters pop more. We also used levels of detail a lot. We would have really lush, detailed trees in the foreground that would fade into simple graphic shapes as they receded into distance, so much so that they blended seamlessly in with the matte paintings, which were very iconic and graphic styled. So that were some of the challenges that we had to overcome. Often we would use gradients and vignettings, very simple tricks like to grad the background darker as it approached the horizon, or to grad it darker moving left to right, depending on where the characters were. or simple stuff like vignetting the edges of the screen to be darker and slightly out of focus, just to make the characters pop a little bit more. All very simple tricks, but very effective when you're dealing with a very two-dimensional looking production design. Obviously, Maya was very useful to us as an animation tool, but it was also useful to us as a lighting, rendering, and look development tool. We used Maya's shader node network to very quickly develop the look of hundreds and hundreds of props on open season. It was very useful to us because of Maya's fast interactive GL display as well as texture GL display. We were able to create looks for these props very quickly and then write out RenderMan code to put it actually into the movie. Additionally, using Maya's hair system and a GL display gave us a great launching point for our own hair system. ImageWorks has had a very robust and powerful hair system, probably the best in the business, for quite some time. And we used Maya to leverage off their hair system and their GL display to create our own proprietary combing, clumping, look development tools. So yeah, Maya came in handy on the rendering side of things as well. How the lighting process generally worked on open season, we would get our data from animation, and we would get our color keys from the art department. And myself as supervisor would sit down with my team of lighters, and we would go over the color keys and the animation separately and figure out how we were going to get to the visual goals defined by the art department and the directors. So once we did that, we'd start generating first passes of lighting, and I would be the first step of approval to decide whether or not we were getting there. The next step would be putting it in front of the art director and my boss, the visual effects supervisor, and we would determine whether or not it would be good enough to go in front of the directors, who would be, of course, the last system of approval. And I think it was an exciting process for even the most junior lighter all the way up to the directors, because there was a lot of interaction and a lot of communication right off the bat. Lighters often have to deal with, in a CG animated feature, a very strong character design, and sometimes that translates into some very aggressively textured characters. And so one of the things you sort of have to tackle on every CG feature is just how much detail do you see in texture, especially when you get close to a character. On this movie, the directors weren't terribly interested in creating a very photoreal look. In fact, early on, they were thinking they wouldn't even have real hair. But we, of course, showed them a hair design that was both detailed but iconic looking. So one of the things lighters had to deal with was trying to figure out just how much texture do we show in this movie. Things like dirt maps and fingernails and subsurface scatter maps in the skin all had to be dialed down to reduce the amount of detail so that the characters, their detail was not distracting from their very iconic design. Subsurface scattering describes how a light ray reacts when it hits a semi-translucent surface that has depth. Meaning as a light ray hits a particular value, a particular point on a character's skin, it also samples the value of an area of skin around it and how much that area of skin contributes to that original point. So it really helps for surfaces that are semi-translucent, like skin, marble, ice, snow, things that have some kind of translucence to them and yet are not transparent, it really helps to have this subsurface scatter algorithm. So you've got this kind of glowy look to it. We use subsurface scattering almost exclusively for skin on open season. Fur is unique in that fur has its own kind of subsurface scattering built in because fur is generally semi-transparent. As light enters a furred animal, generally the fur without shadows is completely glowy and bright and opaque. And then once you start calculating the shadow contribution between hairs, you start getting detail in the hair, and you start saying this amount of hair has this amount of transparency, and conversely it's affected by the shadowing of this amount of hair. So that's one reason that hair can be also really expensive to render, not because there's millions of them, but because you're not only calculating the value of the hair itself, but the contribution of the hair around it. On this particular CG feature, we actually found we could push the lighting a lot farther than we could in an average visual effects show. Obviously, in a visual effects show, you're going for something that looks photoreal. You want it to integrate. So there's usually a very defined target you have to hit. In this particular movie, since we had such extreme art direction, the lighters found that they could really push their lighting a lot. Often the directors would say, you know, saturate it up another 50%, and when they really meant saturate it up another 200%. So it was definitely kind of fun and exciting that way, because lighters generally who have worked in visual effects are usually used to working in with this very square kind of regimented range, and on this movie we just threw that away, and you know, our key fill ratio, you know, our ratio between light and dark on the characters was way higher, and their shadows were raking and long, and their colors were made really saturated during the day and then made really monochromatic at night. So there was definitely a lot of play in the color and lighting design on this movie. Recommended reading for those who aren't handy with a pencil, Drawing on the Right Side of the Brain by Betty Edwards is essential reading. Definitely very useful for your average lighter or shader writer. And then also for your average lighter, compositor, technical director, the American Cinematographer's Manual is the Bible. And you pair that with your average visual effects compendium, like Exploring Visual Effects or a book like that, and you'll be set. You'll be able to talk about anything in the field. The future of CG in both animated features and live action features, I see the 3D IMAX viewing experience becoming much more robust and intuitive. I also see all digital photoreal characters and sets being taken to the next level in movies like Beowulf, kind of how they started in Polar Express and taking that to the next level. I see a lot more virtual sets being created, like what we saw in the Da Vinci Code in the Saint-Sulpice scene, where the characters are shot over green screen, but the entire set is CG. There will always be a director or a studio that wants to do the next impossible task, and I don't see the visual effects industry or CG industry becoming complacent about it. I've worked on 14 or 15 different movies, and I've never finished a movie and said, "Whew, that was easy." So I got my start in the industry by first getting a degree from Ryerson in Toronto in film and video. And after that, I went to the International Academy of Art and Design and got my diploma in computer animation. And then I sent my reel out everywhere and didn't get a lot of response. This was 10 years ago. And then decided to go to SIGGRAPH in New Orleans in 1996. And that all changed for me. So my advice for getting started in the field is just talk to people. Definitely, whether it's just talking to recruiters at SIGGRAPH or calling up the recruiters at your local little effects house, or just talking to your instructors at your school. Just learn to talk to people. You don't feel like you have to sell yourself very hard, but let people know that you're out there. Another piece of advice would be don't be afraid to start small. One of the great things about working at a small post house is that you get to do a little bit of everything. If you find you can't get a job at a small post house, look at getting a job at a animation school. You'll certainly learn a lot there just by going over what you know with other people. Definitely learning as broad a skill set as you can will enable you to become a generalist. And generalists are very highly valued at the larger studios. Another piece of advice would be to learn to draw, even a little. Even if you are just interested in lighting or shader development, it's great to be in a position to sketch really quickly a quick idea. Even in lighting, you find yourself wanting to render things very quickly on a piece of paper to communicate an idea. So, learn to draw even a little bit. Definitely helps a lot.